In this video, we'll start looking at oxidation reduction reactions, specifically starting with oxidation numbers. When we first look at an oxidation reduction reaction, or a redox reaction for short, that involves the transfer of electrons between reactants. You can't have an oxidation without a reduction occurring, so you can't have one without the other. If we look at our redox reaction, we can see we have one atom will donate electrons to another. The one that donates the electrons goes through an oxidation. The one that accepts the electrons goes through a reduction. With this premise, we know we always have to have the oxidation reduction occurring simultaneous. Now, in order to remember which one is gaining or losing electrons, we can use a mnemonic device. One of them we can use is called oil rig. Oil is oxidation is loss of electrons. Rig, reduction, is gain of electrons. So if we look at X going to Y, X is oxidized by Y. X is losing its electrons to Y. X is therefore a reducing agent. X will increase its oxidation number. Y, the one that is receiving the electrons, is being reduced by X. So Y is gaining electrons, which means Y is an oxidizing agent. Y is also decreasing its oxidizing number. So now that we know some of the terms about oxidation reduction, and we know when we're talking about something being oxidized, it's losing electrons. When something's being reduced, it's gaining electrons. And we notice the oxidation numbers changing. That's what we're going to focus on in this video, oxidation numbers. So the oxidation number is used to determine if a redox reaction has occurred. So we assign an oxidation number or an oxidation state to each element, whether it's in a neutral compound or a charged compound. If we look at our element lead to oxide and carbon monoxide going into lead and carbon dioxide, we can assign an oxidation number for each element present. The lead, since it's a +2 charge, has an oxidation number +2. Oxygen has an oxidation number of -2. The carbon here has an oxidation number of +2, and the oxygen has an oxidation number of -2. When the lead is in its elemental form, its oxidation number is 0, since we have a neutral atom. Carbon becomes a +4, and oxygen becomes a -2. So we can see that the lead goes from a +2 charge to a 0. It is gaining electrons. The carbon is going from a +2 to a +4. It's lost 2 electrons. So you can see however many electrons one atom gains, the other atom has to lose. Now, I'm sure your question is, how do we assign these oxidation numbers? Where did they actually come from, particularly for the carbon? Well, we have rules for our oxidation numbers. If an element is in its elemental form, its oxidation number is 0. So examples, if I have H2, hydrogen would be a 0. A metal in its natural state would be a 0. O2 would be a 0. S8 is actually the elemental form of sulfur, so that would be a 0. P4 is the elemental form of phosphorus, so that'd be a 0. So all of these would have an oxidation number of 0. If it's a monoatomic ion, its oxidation number will be the same as its charge. So that's how we got the +2 for the lead and the -2 for the oxygen. So if magnesium can form a +2 charge, its oxidation number is 2. Bromine forms a -1 charge, so its oxidation number is -1. Iron +3 ion, or the iron 3 ion, has an oxidation number of +3 because it's charged 3. And our oxidation numbers are positive for metals and negative for nonmetals. So you can see the oxidation number can either be a positive or a negative. Some elements have fixed oxidation numbers. Oxygen is one of those that has a fixed oxidation number. It always has an oxidation number of -2. With one exception of the peroxide ion. If we remember, peroxide ion is O2 minus 2. Each oxygen in the peroxide ion has a -1 charge, and therefore has an oxidation number of -1. So if I have something like water, oxygen would have an oxidation number of -2. If I have hydrogen peroxide, oxygen would have an oxidation number of -1. Hydrogen is -1 when it's bonded to a metal. We tend to not see these in Chem 1A here. And then hydrogen is a +1 when it's bonded to a nonmetal. So we can see oxygen is a nonmetal, so hydrogen is +1. Lithium is a metal, so that's how we get hydrogen as -1. We're not going to see these really in Chem 1A. You may see them later on. But so anything where hydrogen is bonded to the nonmetal, hydrogen has a +1 oxidation number. A couple other ones. Fluorine always has an oxidation number of -1. So a fluoride has a -1 charge, so its oxidation number is -1. Other halogens typically have an oxidation number of -1. But the other halogens, chlorine, bromine, and iodine, can also have positive oxidation numbers, usually when they're in a polyatomic ion, so when they're an oxyanion. So example, when we have hydrochloric acid, HCl, chlorine has an oxidation number of -1, hydrogen has an oxidation of +1. However, when we turn into a polyatomic ion and we have hypochlorous acid, oxygen has to have that -2 oxidation number. Hydrogen has to have the +1. So then we have to figure out what the chlorine is. So we can, if we don't know that chlorine's a +1, we can set up an equation where we have hydrogen, oxygen, and chlorine has to equal 0 because the molecule has an overall charge of 0. I know hydrogen has to be a +1, oxygen is a -1, chlorine's still 0. So when I move these numbers over to the other side of the equation, we end up with a +1, which therefore is the oxidation number for chlorine. We can also do this for other polyatomic ions. So if we had perchloric acid, we can do the same thing. Set it up where hydrogen is a +1. Each oxygen would be a -2. So I'd have hydrogen plus 4 oxygens plus chlorine equals 0. So we'd end up with +1 plus 4 times -2 plus chlorine equals 0. And then when we solve for the chlorine, chlorine has an oxidation number of +7. So you can see how the chloride ion is the one that it changes its oxidation number depending on the polyatomic ion it's with. And so the sum of the oxidation numbers for a polyatomic ion is going to equal its charge. So we can still set up the same equation, except you can see we don't have a hydrogen present. So we'd have a chlorine plus 4 oxygens equals, and we look at the charge of the polyatomic ion. Here it's a -1. So it'd equal -1. So we'd set up as chlorine plus 4 times -2 equals -1. And then when you solve for chlorine, you still get that +7. So we can use this idea of assigning oxidation numbers to see if we had a redox reaction occur or not. And so one thing to remember, the oxidation of an element is accompanied by an increase in its oxidation number, and the reduction is accompanied by a decrease in the oxidation number. You guys should be able to assign oxidation numbers to each element in a formula. And then we'll see next time looking at a full redox reaction to see how the oxidation and the reduction occur. And so our next video will focus on redox reactions and balancing redox reactions.